National Electrical Code Section 500.7 permits the use of explosive gas monitors as an alternative to explosion-proof wiring methods in certain hazardous locations. These monitors must meet specific requirements to ensure they effectively detect and respond to the presence of explosive gases. According to National Electrical Code Section 500.7 BOEM, explosive gas monitors must firstly be approved for the specific hazardous location, secondly, be capable of detecting the specific gases present in the hazardous location, thirdly, continuously monitor the atmosphere for the presence of gases, fourthly, sound an audible alarm and activate a visible indicator when the concentration of gases exceeds the lower explosive limit, or LEL, and fifthly, automatically disconnect the power supply to the electrical equipment in the hazardous location within 30 seconds of the alarm sounding. Based on the information provided, ITrans fixed-point monitors and audible/visual signaling devices appear to meet the basic requirements of National Electrical Code Section 500.7 BOEM. They are capable of detecting gases, sounding alarms, and activating visible indicators. Fault contacts in the monitor, which indicate a fault in the system, are not specifically required by National Electrical Code Section 500.7 BOEM. However, they are strongly recommended for enhanced safety. There are a number of additional considerations as well. Firstly, the monitor should be installed and maintained in accordance with the manufacturer's instructions and applicable codes and standards. Secondly, the audible and visual alarms should be clearly audible and visible in the hazardous location. Thirdly, the electrical equipment being protected by the gas monitor should be rated for the specific hazardous location. In conclusion, ITrans fixed-point monitors and audible/visual signaling devices combined with fault contacts can be considered a suitable option for meeting the requirements of National Electrical Code Section 500.7 BOEM for explosive gas monitors. However, it is important to ensure proper installation, maintenance, and testing of the system to ensure its effectiveness and safety. This includes ensuring the monitors are approved for the specific hazardous location. Approval signifies that the equipment has been tested and certified by a recognized testing laboratory to meet the stringent safety standards required for use in environments where explosive gases may be present. The approval will typically be indicated by a listing mark from organizations such as Underwriters Laboratories, commonly known as UL, or similar certification bodies. This is vital because it provides assurance that the monitor is designed to operate safely and reliably in the intended hazardous environment. The capability to detect the specific gases present in the hazardous location is paramount for the effective functioning of the gas monitoring system. The sensors within the monitor must be sensitive and responsive to the particular gases that pose a risk in that environment. Different gases have different chemical properties and require specific sensor technologies for accurate detection. For example, a sensor designed to detect methane will not be effective for detecting hydrogen sulfide. Therefore, careful consideration must be given to the selection of monitors equipped with sensors tailored to the specific gases expected to be present. This information is usually available in the product specifications provided by the manufacturer. Continuous monitoring of the atmosphere for the presence of gases is a fundamental requirement for ensuring a safe environment. The gas monitor must operate without interruption, constantly sampling the air and analyzing it for the presence of explosive gases. This continuous vigilance allows for early detection of gas leaks or accumulations, enabling prompt action to prevent potentially dangerous situations. The monitoring system should be designed to operate reliably over extended periods with minimal maintenance requirements. Regular calibration and testing are necessary to maintain accuracy and ensure the system remains effective in detecting gas hazards. Sounding an audible alarm and activating a visible indicator when the concentration of gases exceeds the lower explosive limit is a critical safety measure. The lower explosive limit, or LEL, represents the lowest concentration of a gas in air that will support combustion. When the gas concentration reaches or exceeds this level, there is a significant risk of explosion if an ignition source is present. The audible alarm serves to alert personnel in the vicinity to the potential danger, while the visible indicator provides a clear visual warning. The alarms should be easily noticeable and distinguishable from other alarms in the area to avoid confusion. The alarm system should be designed to operate reliably and provide sufficient warning to allow for timely evacuation or other safety measures. Automatically disconnecting the power supply to the electrical equipment in the hazardous location within 30 seconds of the alarm sounding is a vital safety feature. This automatic shutdown helps to eliminate potential ignition sources and prevent an explosion. Electrical equipment, if left energized, can generate sparks or heat that could ignite the explosive gases. By quickly cutting off the power supply, the risk of ignition is significantly reduced. The automatic shutdown system should be designed to be fail-safe, ensuring that the power is disconnected even in the event of a system malfunction. Regular testing and maintenance are necessary to verify the proper operation of the shutdown mechanism. While fault contacts in the monitor, which indicate a fault in the system, are not specifically required by National Electrical Code Section 500.7 BONE, they are strongly recommended for enhanced safety. Fault contacts provide a means of detecting malfunctions or failures within the gas monitoring system itself. These faults could include sensor failures, communication errors, power supply issues, or other problems that could compromise the system's ability to accurately detect gas hazards. By incorporating fault contacts, the system can provide an early warning of potential problems, allowing for timely corrective action to be taken. This helps to ensure that the gas monitoring system remains operational and effective in protecting against explosive gas hazards. The monitor should be installed and maintained in accordance with the manufacturer's instructions and applicable codes and standards. Proper installation is crucial for ensuring the monitor's effectiveness. The location of the monitor should be carefully selected to ensure it can accurately detect gas concentrations in areas where leaks are most likely to occur. The monitor should be mounted securely and protected from physical damage. Wiring connections should be made in accordance with the manufacturer's instructions and all applicable electrical codes. Regular maintenance is also essential for ensuring the monitor continues to operate reliably. This includes periodic calibration, sensor replacement, and cleaning. The audible and visual alarms should be clearly audible and visible in the hazardous location. The alarms should be easily noticeable and distinguishable from other alarms in the area to avoid confusion. The audible alarm should be loud enough to be heard above the ambient noise levels in the hazardous location. The visual alarm should be bright enough to be seen even in direct sunlight or other bright lighting conditions. The alarms should be located in areas where they are easily visible and audible to personnel who may be at risk. The electrical equipment being protected by a gas monitor should be rated for the specific hazardous location. Electrical equipment used in hazardous locations must be specially designed and certified to prevent explosions. This equipment is typically enclosed in explosion-proof housings that can contain any internal explosions without igniting the surrounding atmosphere. The equipment must also be designed to limit surface temperatures to prevent ignition of explosive gases. The rating of the electrical equipment must be appropriate for the specific hazardous location where it is being used. This rating is based on the type of gas or vapor present, the concentration of the gas or vapor, and the likelihood of an explosion. It is important to ensure that all electrical equipment used in the hazardous location is properly rated and installed in accordance with all applicable codes and standards. In summary, the use of ITrans fixed-point monitors and audible/visual signaling devices, combined with fault contacts, can be a suitable option for meeting the requirements of National Electrical Code Section 500.7 BONE for explosive gas monitors. However, it is crucial to ensure proper installation, maintenance, and testing of the system to guarantee its effectiveness and safety. This comprehensive approach will help to protect personnel and property from the dangers of explosive gas hazards. The selection and use of explosive gas monitors as an alternative to explosion-proof wiring methods are governed by specific requirements outlined in National Electrical Code Section 500.7. These requirements aim to ensure that the gas monitors provide a level of safety equivalent to that provided by explosion-proof wiring methods. Explosion-proof wiring methods involve the use of specialized conduit, fittings, and enclosures designed to contain any explosions that may occur within the electrical system. These methods are typically used in hazardous locations where explosive gases or vapors are present. However, the use of explosion-proof wiring methods can be costly and time-consuming. As an alternative, National Electrical Code Section 500.7 permits the use of explosive gas monitors under certain conditions. The gas monitors must meet specific requirements to ensure they effectively detect and respond to the presence of explosive gases. These requirements include approval for the specific hazardous location, the ability to detect the specific gases present, continuous monitoring of the atmosphere, audible and visual alarms, and automatic power disconnection. The use of explosive gas monitors can offer several advantages over explosion-proof wiring methods. Gas monitors can provide continuous monitoring of the atmosphere, allowing for early detection of gas leaks or accumulations. This can enable prompt action to prevent potentially dangerous situations. Gas monitors can also be more cost-effective than explosion-proof wiring methods, especially in large or complex installations. However, it is important to ensure that the gas monitors are properly selected, installed, and maintained to ensure their effectiveness. Regular calibration and testing are necessary to verify the accuracy of the monitors and ensure they are functioning properly. Personnel must also be trained on the proper use and maintenance of the gas monitoring system. When selecting an explosive gas monitor, it is important to consider the specific hazardous location where it will be used. The hazardous location classification will determine the type of gas or vapor present, the concentration of the gas or vapor, and the likelihood of an explosion. The gas monitor must be approved for the specific hazardous location and be capable of detecting the specific gases or vapors present. It is also important to consider the environmental conditions in the hazardous location. The gas monitor must be able to operate reliably in the expected temperature, humidity, and other environmental conditions. The monitor should also be resistant to corrosion and other forms of damage. The installation of the explosive gas monitor must be performed in accordance with the manufacturer's instructions and all applicable codes and standards. The monitor should be located in an area where it can accurately detect gas concentrations. The monitor should also be protected from physical damage. Wiring connections should be made in accordance with the manufacturer's instructions and all applicable electrical codes. Regular maintenance is essential for ensuring the explosive gas monitor continues to operate reliably. This includes periodic calibration, sensor replacement, and cleaning. The frequency of maintenance will depend on the type of monitor, the environmental conditions, and the manufacturer's recommendations. It is important to keep records of all maintenance activities. Personnel must be trained on the proper use and maintenance of the explosive gas monitoring system. Training should cover the following topics: firstly, the principles of gas detection; secondly, the operation of the gas monitor; thirdly, the interpretation of gas readings; fourthly, the proper response to gas alarms; and fifthly, the maintenance of the gas monitor. In addition to the requirements outlined in National Electrical Code Section 500.7, there may be other applicable codes and standards that must be followed. These may include local building codes, fire codes, and industry standards. It is important to consult with qualified professionals to ensure that all applicable codes and standards are met. The use of explosive gas monitors can provide a valuable safety measure in hazardous locations. However, it is important to ensure that the monitors are properly selected, installed, and maintained to ensure their effectiveness. By following the requirements outlined in National Electrical Code Section 500.7 and other applicable codes and standards, it is possible to create a safe working environment in hazardous locations. This includes a regular check of the sensor elements to determine if they have reached their end of life. The manufacturer's instructions must be carefully reviewed to understand the lifespan of the installed sensors. Some sensors are designed to last for a couple of years, for example, while others might last longer. When the sensor reaches the end of life, it must be properly replaced to make sure that the sensors are operating in proper condition.